Hello. Today we're going to show you how to use the high flow filtration system on this Groundsmaster 4700. The high flow filtration system is an excellent tool to be used after a repair of the closed loop hydraulic system or as a service procedure.
The filter assembly weighs about 60 pounds. Here are the rest of the specifications. To begin installing the filter system, you will need an assortment of large open-end wrenches, the filter assembly, and the high-pressure hose kit. The high-pressure hose kit is designed to provide quick and easy installation of the filter system to a closed-loop traction system. The hose kit is also used when installing the high-volume flow meter. The unique design of the Toro filter system is that the manifold contains 4 check valves. These check valves create a unidirectional filter flow. The design and check valve feature prevents recontamination if the flow direction changes unexpectedly and eliminates cross-contamination when changing units. The high-pressure, high-flow filter uses the machine's pump flow to dislodge, retain, and remove destructive floating particles from a closed-loop hydraulic circuit. The filter system can clean up a contaminated closed loop after repairs or be used as an upsell to customers when providing routine or seasonal maintenance programs. This additional filtration process will proactively clean a functioning circuit, potentially extending uptime. Installing the filter so oil flow is as shown will capture contaminants and protect downstream components. Pulling a vacuum on the hydraulic reservoir allows you to connect the filter assembly with minimal leakage. Here's an example of a tool you can make. Modify a hydraulic reservoir plug and connect it to a vacuum adapter. There's no need to glue the parts together, and a small 1/4-inch hole allows you to adjust the vacuum. Now we're going to connect the shop vac to the hydraulic reservoir. The dipstick and screen are removed. Screw the adapter into the tank, connect the hose from the vacuum cleaner, and turn the vacuum on. It's that simple. Connect the filter to the removed hose and the transmission fittings. This is a typical location you would utilize to install the filter kit. After disconnecting, check the O-rings to make sure they're not damaged and replace if required. Tighten high-pressure fittings securely to prevent any leakage. Check and refill the hydraulic reservoir before proceeding. Suspend the wheels, uncouple the maneuvering brakes, start the engine, and release the parking brake. Operate the traction pedal in both directions for about 5 minutes. Reduce speed if the differential indicator turns red. If required, utilize maneuvering brakes to force both front wheels to rotate from one side to the other. Increase engine speed to full and repeat the process. At full speed, be gentle with the maneuvering brakes since pump flow may exceed maximum wheel motor flow. Continue for 5 minutes. After filter removal, reinstall the original hoses. Use a torque wrench to tighten the fittings to the correct torque, or use the flats from finger tight method. Now we're going to replace the filter element. The canister is being removed for filter replacement. Be careful because the canister is quite heavy and the threads are very fine. The canister and filter element are sealed with O-rings. The filter element simply pulls away from the head. A drain pan is a very handy tool to use in this situation. Make sure the O-ring is not damaged. It takes about 13 revolutions to remove or install the filter canister. Snug up the canister or torque to 25 foot-pounds. The restriction gauge monitors differential pressure. Green is normal. If cold oil causes a red indicator, reduce flow and slowly increase as the oil warms. Replace the filter if the indicator is red. To complete the filtering process, replace any exposed O-rings and replenish the reservoir when finished. This completes our demonstration. Thank you.